In the Level 1 video, we explored beginner-friendly built-in functions for the CCS C compiler. In this video, we're looking at built-in functions related to interrupts and timers. We're also introducing driver files that expand on available functions and example programs that you can copy code from. Timers can run in the background and trigger interrupts. This timer interrupt demo shows how to use the timer 1 interrupt to blink an LED without stopping the rest of the program. The int timer 1 line tells the CCS C compiler that the function timer 1 ISR is the interrupt handler for timer 1. Every time timer 1 overflows or reaches a defined compare value, this function gets called automatically. The demo timer interrupt function calls the built-in function setup timer 1 to start timer 1. The arguments configure timer 1 to use the internal clock and divide that clock by 8 to slow it down. The set timer 1 built-in function sets a specific time interval. The number passed in is the start value. Because timer 1 is a 16-bit timer, the value goes up to 65,535. This means that after 62,500 ticks, timer 1 overflows and calls the timer 1 ISR function. Each increment of timer 1 takes 1.6 microseconds. 62,500 ticks multiplied by 1.6 microseconds equals 100 milliseconds. The enable interrupts built-in function turns on the ISR, or interrupt service routine. The global interrupt enable bit needs to be turned on even if a specific interrupt was enabled. The while true line is an infinite loop that causes the main program to sit idle and wait for an interrupt or do whatever else the program needs to do. Now the LED toggles without blocking the CPU. An external interrupt is a signal that comes from outside the microcontroller and tells the CPU to stop what it's doing and immediately run an ISR. #INTEXT is a CCS compiler directive that tells the compiler that the following function, in this case the ext ISR function, is the ISR for the external interrupt. This function toggles a yellow LED. The demo ext interrupt function sets up and enables the interrupt system. The built-in function, port B pullups, enables the internal pull-up resistor for input pins on port B. The extInt edge built-in function lets us pick rising or falling edge detection. Falling edge is when the signal goes from high to low. This is useful for detecting button presses if the button pulls the line low. External interrupts are great for reacting instantly to events without constantly checking in a loop. Now the yellow LED will turn on or off when the button is pressed. The use RS-232 line indicates that this stream uses the ICD in a special pass-through mode to send and receive serial data to and from the PC. The getEnv built-in function obtains information about the execution environment based on the recognized keyword passed in. Predefined identifiers can be used to display information about the project, such as the last build date and time and the C file's filename. The kbhit built-in function checks if a character is ready for the getC function. In this example, the information is printed to the terminal through the ICD connection. The prototyping board can be connected to an external EEPROM on a breadboard. The CCS C compiler comes with a drivers folder that contains code with more functions that you can call. To include a driver file, use the #include directive. The driver file that we are including is for the microchip 93C56 EEPROM, which is what we are using. This driver contains the functions init ext EEPROM, which should be called before the other functions, write ext EEPROM for writing, and read ext EEPROM for reading. The data that gets read is printed to the terminal. There are hundreds of drivers available to help you complete your project faster. The CCS compiler also comes with hundreds of example programs that you can look at in the examples folder. Let's look at a project that was created using code from the watchdog timer example program. The watchdog timer is a built-in hardware timer that automatically resets the PIC MCU if your program fails to check in within a set amount of time. It's a safety net for runaway code, lockups, or unintentional infinite loops. Restart cause is a built-in function that returns the cause of the last processor reset. The setup WDT built-in function configures the watchdog timer to time out after about 2.3 seconds. Calling the restart WDT built-in function restarts the watchdog timer before it expires and therefore prevents it from resetting the PIC MCU. In this example, that function is being called inside an infinite loop that waits for a character to be sent to the terminal. If no characters are sent in time, then the watchdog timer times out. If a character is sent, then the watchdog timer restarts. These level 2 functions open up a lot of possibilities. Once you're comfortable with the basics, these tools can help you build more complex PIC MCU projects. Visit ccsinfo.com for more information about the easy-to-use CCS compiler IDE and for purchasing options.